Good morning, class. In this lecture, we will see containers and closures which are used for the packaging of parenteral products. So, we have seen various parenteral products like parenteral injections, parenteral suspensions, parenteral emulsions, parenteral lyophilized powders. So, packaging of these parenteral products, various types of containers and closures are used. So basically, two materials are used for the packaging of products like glass or plastic. So glass and plastic are the two basic materials which are used for the packaging of parenteral product. So either glass or plastic material can be used for packaging of injectable. Various types of containers, various type of container systems like ampoules, vials, syringes, cartridges, bottles, and bags are used for packaging. So you might have seen various types of packaging of parenteral products. Some of them are ampoules, vials, syringes, cartridges, bottles, and bags, plastic bags obviously. Ampoules are made up of glass while bags are made up of plastic. Ampoules and vials, these are made up of glass and rubber closures while bags are made up of plastic. Rubber material is included in container structures such as rubber stopper for vials and bottles, rubber plungers and rubber seals for syringes and cartridges. So rubber material is also used for the packaging of container closures, for packaging of containers, parental products. So the rubber material is included in container structures such as rubber stoppers. तुमच्या कंटेनरच्या वरती जे स्टॉपर्स राहतात ते रबर पासून बनलेले असतात. त्यानंतर रबर प्लंजर्स प्लंजर्स जर तुम्ही बघितले जे इंजेक्शन तुम्ही इंजेक्शन जे असतं ते इंजेक्शन च्या मधला जो पार्ट असतो तो एक रबर प्लंजर असतं. त्यानंतर रबर सील फॉर syringes and cartridges. Following conditions for a container closure must be fulfilled as per pharmacopoeia to be used as a parenteral preparation. So there are certain conditions which should be fulfilled by your container closure systems or material which is to be used for the container closure so that they can be used for the packaging of parenteral product. So the first one is that material should not leach foreign substance into the product. So material should not sometimes what happens like if plastic is there, plastic may leach its material into the like plasticizers into the product. This leaching may cause change in pH, change in alkalinity of preparation. So the one of the requirement for a material to be used for the packaging of parental product is that material should not leach its components into the parental product. For visual inspection of the content, container closure should be transparent. Okay, this one is simple one. If you want to visualize the product from outside, then that the container system should be transparent in nature. It should not have adverse effect on the product. In case of parental product, stability, sterility, then pyrogen freeness are some important parameters, and these parameters should not be affected by particulate content. These parameters should not be affected by container closure system. It should prevent diffusion in or across the walls. So product should not get diffused through the walls of the container. Then types of containers. So types of container are basically classified depending upon the material which is used for the manufacturing of that container. So first one is a glass. So glass is most commonly used container for the packaging of parenteral product. According to USP, there are four types of glasses which are as follows. So type 1 glass, type 2 glass, type 3 glass and type 4 glass. Type 1 glass is a neutral or also called as a borosilicate glass. Type 2 glass is called as a treated soda lime glass. Type 3 glass is called as a regular soda lime glass or soda lime glass of limited alkalinity. And type 4 glass is also called as a soda lime glass which is not suitable for containers for parental product. So type 1, type 2, type 3 glasses are generally used for the packaging of parental product, while type 4 glass is not used for the packaging of parental product. Generally, glass is made up of silica, and along with silica, various excipients are added in the manufacturing of glass. And depending upon that, glass is type 1, type 2, type 3, and type 4. So, type 1 glass. So, type 1 glass is also called as a borosilicate glass or neutral glass. Type 1 glass is also called as a borosilicate glass or neutral glass. So, it offers a high hydrolytic resistance due to the chemical composition. Now, what mean by high hydrolytic resistance? So, as you know that lytic means lysis means to break down. So, hydrolytic resistance is provided by type 1 glass due to its chemical composition. It can withstand autoclaving and weathering. So, this type 1 glass can be autoclaved or it can be sterilized by using autoclave. As it has the highest resistance to leachables, permeation and adsorption, type 1 glass is suitable for all parental product. So highly resistant to leachables, that is, contents of glass do not leach into the product. Then permeation means the product which is inside the glass or the outside environmental factors do not permeate inside the product or product do not permeate outside the glass container. And adsorption means what sometimes occur. So content of the product may adsorb on the glass container. So type 1 glass is most useful glass as it does not leach, it does not cause permeation and adsorption. One of the characteristics of this glass is that it has a low thermal coefficient of expansion. Sulfur dioxide treatment is used for greater resistance to leachables. So this glass is treated with sulfur dioxide, and as it is treated with sulfur dioxide, the leachable material amount is reduced. Plasma impulse chemical vapor deposition, that is PICVD, plasma impulse chemical vapor deposition technology developed by Scott AG is used to coat the inner surface of type 1 glass vials with an ultra-thin film of silicon dioxide. So this plasma impulse chemical vapor deposition technology is used for the coating of the inner surface of the glass with sulfur dioxide. And as sulfur dioxide coating is carried out, the amount of leachables from the container into the product is highly reduced. This film practically eliminates glass leachables by forming the highly efficient diffusion barrier. Due to the formation of the film of silicon dioxide, not sulfur dioxide, due to the formation of thin film of silicon dioxide on the inner surface of the glass container, the leachables means the material of container which gets diffused inside the parental product is very much reduced. Then type 2 glass. It is a soda lime silicate glass. As a result of treatment with moist sulfur dioxide at high temperature, this glass has a high hydrolytic resistance. The container made from this glass are suitable for most acidic and neutral aqueous preparations. Then type 3 glass. It is a soda lime silicate glass with only moderate hydrolytic resistance. Injectable products like non-aqueous and powder for reconstitution are suitable for filling in this glass. So hydrolytic resistance, the word itself is indicative, that is water attacks on the surface of the glass. And because water attacks on the surface of the glass, the amount of leachables and the amount of permeation or the amount of adsorption is increased. So in order to uh, uh, form a perfect container for packaging of parental product, the glass should have high hydrolytic resistance. That is, glass should not be get easily attacked with water. And to prevent this, generally type 1 glass, type 2 glass is coated with silicon dioxide. Now type 3 glass is having low hydrolytic resistance, means in this glass we cannot fill a aqueous product or the watery vehicle product. So instead of that we can fill non-aqueous vehicles inside this container, or we can fill powders for reconstruction inside this vehicle. Then type 4 glass. So this type of glass is not used for parenteral purpose. Remember this, only type 1, type 2 and type 3 glass used for the packaging of parenteral product. Then how these glass are tested? Testings of glass. So two USP tests are as follows are used for determination of glass type. That is powder glass test and water attack test. So powder glass test and water attack test. So first one is a powder attack test. Alkaline constituents like oxides of sodium, potassium, calcium, aluminum, etc. are leached from the glass container into the purified water under conditions of elevated temperature. Which means that if you increase the temperature of glass container, then the amount of leachable substances like sodium, oxides of sodium, potassium, calcium, aluminum gets increased gets increased under high temperature into the purified water. And when the glass is powdered, the leaching of alkali can be enhanced in the powder is critical. In the preparation is critical. So what is powder is there? Our product is critical. Now, when glass is intact or container is intact, the surface area coming in contact with product is less. But when that glass is converted into powder form, at that time the glass container powder glass test is carried out. So estimation of the amount of alkali leached from the glass powder is the principle involved in the powder glass test. So powders are glass is powdered, and after powdering of the glass, at this powder glass is kept in contact with purified water at elevated temperature. Due to this, there may be increase in the leaching of amount of alkali from the powder, and that amount of alkali leached into the product is then checked, and depending upon that, amount of alkali leached in the product is determined. The basic analysis involves titration of acid and base by using methyl red as an indicator. As already seen that in the water alkali is leached. water मध्ये काय होते अल्कली लीच होते आणि अल्कलीचं म्हणजे अल्कोलीचं कॉन्सन्ट्रेशन किती आहे हे जर डिटरमाइन करायचं असेल तर ऍसिड बरोबर काय करायचं टायट्रेशन. ऍसिड बरोबर टायट्रेशन केलं की तुम्हाला त्या अल्कलचं कॉन्सन्ट्रेशन भेटेल आणि या टायट्रेशनसाठी जो इंडिकेटर यूज केला जातो त्याचं नाव आहे मिथिल रेड. Amount of acid that is necessary to neutralize the released alkali is determined, and to pass the test it should be in the specified limits as per pharmacopoeia. मग हे जे ऍसिड लागलं तुमची जी अल्कली लीच झालेली आहे तुमच्या कंटेनरमध्ये, ते अल्कली जे लीच झालेली त्याचं डिटरमाइन करण्यासाठी जे ऍसिड लागलं मिथिल रेड इंडिकेटर यूज केला आपण, ते जे ऍसिड लागलं जे अमाऊंटचं ऍसिड लागलं त्याची जी क्वांटिटी आहे ती जी फार्माकोपियामध्ये लिमिट दिलंय त्याच्यापेक्षा जास्त नको, तरच तुमची पावडर ग्लास टेस्ट काय होणार तुमची पास होणार आहे. सेकंड टेस्ट आहे वॉटर अटॅक टेस्ट. This test is used only with the container that have been exposed to sulfur dioxide fumes under controlled humidity conditions like type 1 and type 2 glass. Such a treatment neutralizes the surface alkali. Now the glass becomes chemically more resistant. Due to treatment with sulfur dioxide, glass becomes chemically more resistant. Determination of amount of alkali leached from the surface of the container is within the specified limits or not is the basic principle behind water attack test. Entire container like ampoules and vials has to be used. The leaching of alkali is accelerated using elevated temperature for a specified time. Now in powder glass test, container is converted, the glass is converted into powder form and then kept with purified water at elevated temperature. But in case of water attack test, the entire container used for the testing, and this entire container is filled with specified amount of water and it is kept at elevated temperature. Now the leaching of alkali is accelerated using elevated temperature for a specified period of time. The amount of acid that is necessary to neutralize the released alkali from the surface is estimated by using methyl rate as an indicator. Okay. Now, what are the limits of water attack test and powder glass test? What are the limits of water attack test and powder glass test for type 1, type 2 glass? So in case of powder glass test, type 1, if type 1 glass is there, then the amount of acid which is used for neutralization of alkali, the type of amount of acid, the type of acid is 0.02 normal H2SO4. So 0.02 normal H2SO4, 0.02 normal H2SO4 for type 1 container should not be more than 1 ml. Should not be more than 1 ml. And if the amount of alkali acid 0.02 normal acid H2SO4 is more than 1 ml, then we can say that powder glass test failed. In case of type 3 container, 8.5 ml, and in case of type NP, that is non-parenteral, it is a 15 ml. Then limits for water attack test. For type 2 test, 100 ml or less. Means if the size of the container is 100 ml or less, then amount of alkali should be less than 0. Amount of acid 0.02 normal acid H2SO4 should be less than 0.7 ml, and in case of type 2 glass which is having higher volume, that is volume more than 100 ml, the amount of acid 0.02 normal H2SO4 required for the neutralization of leached alkali should not be more than 0.2 ml. So these are the limits for powder glass test and water attack test. Then advantages of glass containers. So these are some common advantages of glass containers. So glass containers are mainly used in packaging liquid preparations due to their rigidity and their superior protective qualities. So glass containers are having superior protective qualities. It is high transparency allows easy inspection of its contents. ट्रान्सपरंट आहे त्याच्यामुळे कंटेंट आपल्याला इझिली काय होऊ शकतं, ऑब्झर्व होऊ शकतं. हा एक त्या ग्लास कंटेनरचा ॲडव्हान्टेज का ट्रान्सपरन्सी. नेक्स्ट ॲडव्हान्टेज आहे it offers better protection because it is relatively impermeable to air and moisture as compared to plastic here. So plastic is relatively more permeable to air and moisture, but glass containers are less permeable to air and moisture as compared to plastic. And as these glass containers are less permeable to air and moisture, the stability of product is enhanced. It is chemically resistant to most medicinal products. So what happens generally, the product may react with your container, but glass containers are resistant to the product, medicinal products, and do not react with your chemical products. Then colored glass like amber glass or red colored glass is used for the protection of light sensitive product from the ultraviolet rays. amber color बॉटल तुम्ही यूजच केलेले असतील, त्यासाठी यूज करता तुम्हाला माहिती. then glass containers can be easily sterilized using heat. हा एक त्याचा ॲडव्हान्टेज आहे. ग्लास कंटेनरचं स्टरलायझेशन जर तुम्हाला कॅरी आउट करायचं असतं इझी असतं ॲज कम्पेअर टू प्लास्टिक कंटेनर. देन डिसएडवांटेज ऑफ ग्लास कंटेनर्स. सो फर्स्ट डिसएडवांटेज इट इज expensive to manufacture. Glass containers are expensive to manufacture. Then they are heavy, weight is more, and fragile, that is easily breakable. Okay, it is easily breakable and it is heavy in nature. Now during heat sterilization, some type of glass containers have the tendency of shedding some part of the silica into the formulation. सिलिका पण काय होऊ शकतो, काही फॉर्म्युलेशन मध्ये शेड आउट होऊ शकतो. बरोबर, हा एक त्या ग्लास कंटेनरचे काही डिसएडवांटेज आहेत. त्यानंतर रबर क्लोजर्स. So rubber closures are obtained by vulcanization of macromolecular organic substances, also called as elastomers, with appropriate additives. You must have heard about the process of vulcanization. So process of vulcanization is used for the formulation of, for the preparation of rubber. The elastomers or rubber and appropriate additives like sulfur and other additives are used. These containers are used for aqueous parenteral preparations, for powders and for freeze-dried powders. So rubber closures may be used for the packaging of aqueous parenteral preparations, for the packaging of powders and for the packaging of freeze-dried powders. In the injectable drug products, rubber is used for many applications like closures for vials and bottles, seals and plungers for syringes and cartridges, gaskets in the manufacturing of equipments, and ports on plastic bags and intravenous administration sets. So you can find rubber on various places to be used as a closure system for the packaging of parenteral product. Physical and chemical properties of rubber will decide the best choice of rubber formulation for the product. The best choice of rubber formulation also depends on how it will be used. So if it is used as a closure, septum or plunger, and on the properties of the drug formulation. The physical properties considered in the selection of particular rubber formulation include elasticity. Okay, elasticity is considered, hardness, that is durometer, tendency to fragment. Now this is important parameter which is checked, tendency to fragment. What mean by tendency to fragment? So sometimes what happens when physician insert the needle through this rubber into the vial. Physician insert the needle through this rubber into the vial. Along with that needle, sometimes the particulate matter from that rubber also gets incorporated into the parental product. This should not happen. So tendency to fragment should be less. Then permeability to oxygen and water vapor. Then pressure to puncture, coring, resealability, break force, vacuum retention, and specific leachables, extractables which are present in the rubber closures. So these all parameters are checked before selecting proper rubber closure system. Which are the parameters? Elasticity, hardness, tendency to fragment, permeability to oxygen or water vapor, प्रेशर टू पंक्चर. ओके, सिरिंज आतमध्ये लोटण्यासाठी किती प्रेशर लागत आहे ते प्रेशर टू पंक्चर पण नोट केलं जातं. कोरिंग, रिसिलेबिलिटी अँड ब्रेक फोर्स, देन व्हॅक्यूम रिटेन्शन, देन स्पेसिफिक लिचेबल्स, extractables present in rubber container. Here is one word, coring. This coring indicates again shading of larger portion of rubber inside the product, parenteral product. Elasticity of rubber is critical in establishing a seal with a lip and neck of vial. तर व्हायल वरती सिलिंग होण्यासाठी इलास्टिक कंटेनर रबर क्लोजर काय पाहिजे, इलास्टिक पाहिजे. और अदर ओपनिंग and in resealing after withdrawal of hypodermic needle from a wire closure. बरोबर, निडल इन्सर्ट केली, प्रोडक्ट काढला, निडल बाहेर काढून घेतली. निडल बाहेर काढल्यानंतर जे होल तयार झालेले आहे रबर क्लोजर वरती, ते होल काय झालं पाहिजे, इझिली रिसील झालं पाहिजे, जेणेकरून परत कंटामिनेशन होणार नाही. The needles, the hardness should provide firmness but not excessive resistance to the insertion of needle through the closure. हार्ड पण पाहिजे, पण निडल आतमध्ये जाईल याची एवढा हार्डनेस जास्त नाही पाहिजे. While minimal fragmentation of pieces of rubber should occur as hollow shaft of the needle is pushed through the closure. जास्त प्रमाणात फ्रॅगमेंट्स तयार झाले नाही पाहिजे, कोरिंग झालं नाही पाहिजे. While vapor transfer occurs to some degree with all rubber formulations, appropriate selection of ingredients make it possible to control the degree of permeability. बरोबर, जर तुमचा रबर क्लोजर राहिला, आपण बघितलं ग्लास कंटेनर्स मधून एअर परमेबिलिटी होत नाही, पण रबर क्लोजर राहिलं तर कोणत्याही टाईपचं रबर जर असेल तर त्याच्यातून एअर परमेबिलिटी होऊ शकते किंवा वेपरचे परमिएशन होऊ शकतं. रबर फॉर्म्युलेशन कंटेन अ व्हरायटी ऑफ कंपोनंट्स. The elastomer determines the most physical and chemical characteristics of rubber formulation. The base material for the rubber is the elastomer that is composed of either natural or synthetic रबरचे प्लांट असतात त्याच्यापासून रबर भेटतं तुम्हाला माहित असेल, पण ते रॉ रबर राहतं, त्याच्यावरती प्रोसेस केली जाते, त्या प्रोसेसला म्हणतात वल्कनायझेशन. आणि वल्कनायझेशन करून जे प्रोडक्ट भेटतं ते रबर आपल्याला डे टू डे लाईफमध्ये आपण बघतोय. The earliest source of elastomer material was the natural latex rubber liquid obtained from the Hevia brasiliensis tree. So this is the rubber tree. या rubber tree पासून आपल्याला काय वाटतं latex. तो latex ला आपण काय म्हणतो raw rubber. An increase in demand of the rubber lead to the development in the production of synthetic rubbers. So जशी जशी डिमांड इन्क्रीज होत गेली तसं तसं ट्री पासून भेटणार जे रबर आहे ते कमी पडायला लागलं, म्हणून त्याच्याऐवजी आता सिंथेटिक रबर डिमांड इन्क्रीज झाली म्हणून सिंथेटिक रबर प्रोड्यूस केलं. सिंथेटिक रबर्स include styrene butadiene rubber. In short form, it is called as SBR, styrene butadiene rubber, neoprene rubber, like poly-2-chloro-1,3-butadiene rubber, nitrile rubber, and butyl rubber. Butyl rubber is the most commonly used elastomer for pharmaceutical applications today because of its superior oxygen moisture barrier. So butyl rubber is more resistant to oxygen or moisture or vapors. Hence, it is commonly used in the formulation of packaging of the formulation of parenteral product. Neoprene is halogenated synthetic rubber which is available for more oil-based product. So neoprene is generally used for the packaging of the products which are having oily components. Rubber stoppers are composed of the elastomer like latex, a curing agent, an activator, a filler, as well as additional compounds to control cure rate, color, and resistance properties. Now here is the one word called as a cure. Curing means now rubber latex, which is a basic material which is elastomer used in the formulation of rubber. Now these elastomers are long chains of polymers, and if these long chains of polymers are cross-linked by using suitable agent, then it is called as a curing. Okay, cross-linking of elastomer polymers with suitable agent is called as a curing, and that agent is called as a curing agent. And generally sulfur is used in this process, curing agent, and that process is called as a vulcanization. An activator, a filler, as well as additional compounds to control cure rate, color, resistance properties. The curing agent or vulcanizing agent forms a cross links in the rubber that provide it shape. So cross linking is carried out. The elasticity and the resiliency. So resiliency, elasticity, and shape is obtained by use of curing agent, which is used for cross linking. Sulfur is most common curing agent for elastomers with chemically unsaturated backbones. An activator, typically a metal oxide with a fatty acid, is used to accelerate the rate of which the sulfur react with the unsaturated polymer. So what accelerated do? To basically increase the reaction of sulfur with your unsaturated polymers or elastomers. The most common activator is zinc oxide combined with stearic acid. The control rate of vulcanization acceleration like sulfanilamide and the retardant like benzoic acid, salicylic acid and phthalic anhydride can be added. Fillers are added to reduce the tack, adjust color, and often to increase the hardness and durability. Carbon black, clay, calcium carbonate, and precipitated silica are the example of common fillers. Along with this, antioxidants, anti-ozonates, as well as colorants can be added as an additional additive. Here is one word called as anti-ozonates. So anti-ozonates basically prevent uh, degradation of rubber due to ozones. So these are the different additives which are used in the formulation of rubber closures, and these are the various rubber closures which are used, which you might have seen regularly in the packaging of parenteral products. Then next type of container system is plastic. So plastic is a relatively new material for parenteral packaging. न्यू का म्हटलं जातंय कारण की पूर्वीपासून काय यूज करत आलेले ग्लास आणि रबर. As per an estimate, 60 to 70% of pre-filled syringes in market are plastic rather than glass. Now, what mean by pre-filled syringes? तर तुम्ही पाहिलं असेल फिजिशियनकडे जेव्हा पेशंट जातो तेव्हा डॉक्टरकडे जी सिरिंज असते ती सिरिंज एम्प्टी असते, बरोबर. आणि तो व्हायलमधून डॉक्टर किंवा अँपूलमधून फिजिशियन काय करतो, ड्रग सबस्टन्स ड्रॉ करतो आणि तो पेशंटमध्ये इंजेक्ट करतो. पण प्रीफिल्ड सिरिंजला ते करण्याची गरज पडत नाही, कारण की प्रीफिल्ड सिरिंज म्हणजे ऑलरेडी तुमचा प्रोडक्ट मॅन्युफॅक्चरर कडूनच फिल होऊन आलेला असतो. तर काय करायचं, ते ओपन करायचं आणि पेशंटमध्ये डायरेक्टली काय करायचं, इंजेक्ट करायचं. सिंपल प्रोसेस आहे. Issue with glass breakage and delamination are main concern in the marketplace. तर ग्लासचे जे डिसएडव्हान्टेज आहेत ते ओव्हरकम करण्यासाठी प्लास्टिक मटेरियल यूज केलं जातं. Glass can break at any time in production when used within a device such as auto-injector or even when in use by patient or caregiver. तर ग्लास केव्हा पण ब्रेक होऊ शकते, पेशंटकडून पण ब्रेक होऊ शकते, फिजिशियनकडून पण ब्रेक होऊ शकते. Formation of protein silicone aggregates can be caused by silicone oil, glass lubricant, which may alter the integrity of drug product. तर बेसिकली प्लॅस्टिक काय यूज करायचं, तर जे जे ग्लासचे डिसएडव्हान्टेजेस ते ओव्हरकम करण्यासाठी प्लास्टिक कंटेनर यूज केले जातात. सिरिंजेस, कार्ट्रिजेस, इंट्राव्हेनस कनेक्टर्स, infusion sets, vials, and ampoules can be made up of plastic. Plastic is inert and resistant to broad range of poor solvents, acid and bases. So it is inert one. बेसिकली भरपूर टाईपचे जे API किंवा केमिकल्स आहे ते कोणत्याही प्रकारचे रिॲक्शन दाखवत नाही. ऑल्सो प्लास्टिक प्रोव्हाइड हाय फ्लेक्झिबल आहे. प्लास्टिक ऑफर सिग्निफिकंट डिझाईन फ्लेक्झिबिलिटी. कोणत्याही प्रकारचे डिझाईन आपण त्याचे प्लास्टिकच्या कंटेनरचे बनवू शकतो. जसं ग्लासच्या कंटेनरचं शक्य होत नाही, पण प्लास्टिकच्या कंटेनरचं कोणत्याही टाईपचे डिझाईन आपण बनवू शकतो. अँड इन्क्रीज डायमेन्शनल प्रिसिजन. The commonly used polymers in parenteral packaging are polypropylene, polyethylene, and polyethylene terephthalate, polyvinyl chloride. So these are commonly used plastics in the packaging of parenteral product.